What's up, everybody? Welcome back. So in the last episode we set up a health system and dying along with some animations, and in this episode I want to expand on that because currently we still have our behavior tree and perception running after the AI died. So that's something we need to take care of. And after that I want to take a look at some behavior again and make sure that the AI has a searching state and a chasing state. So first of all, let's take a look at stopping the behavior. So currently the AI dies, but you can see from the blackboard on the gameplay debugger that the current state is still aware, and you can also see that the perception is still tracing me. So I'm still inside, and if I get close, I even trigger combat, and now we have the combat state again. So our blackboard and behavior tree is still running and our perception component is still active. So we want to make sure that shuts down. And then the next thing about the behavior I'm talking about. So if the AI spots us and he starts looking for us, then I feel like he should chase us. So currently he's only going to the last location where he saw us. And over there he's going to just look around. But that's a bit weird because he can still see me. So for as long as he can see me, he should start chasing me. And then if I go around a corner or something, he is going to investigate that location. So that's what we're going to set up as well. And for that, we're going to set up a new state called the searching state to make things a little bit easier. So that's today's episode. Let's start with the dying and stopping our behavior and perception. First of all, let's add a new function inside of our interface for the AI controller. So let's open up the BPI AI controller interface, and in here we're going to add a function to tell the controller that our pawn died. So let's create a new function and call this one AI pawn died. And we don't need to give this any inputs or outputs. So let's compile and save it. And now we want to open up the controller. And in here, first of all, let's take a look at event possess, or on possess actually. So in here, we're using the run behavior tree node, and there is actually no node to stop the behavior tree like this. So we only have a run behavior tree. So we want to tackle this a little bit different. If we add a behavior tree component, then we can start and stop that component, and we can also just destroy the component if we want to. So let's get rid of this node. We're going to delete it. And then let's compile so it's gone. And now we want to add a component over here and look for the behavior tree. And make sure that we set it up in the details panel to use our custom behavior tree. So the AI guard one. And then for event on possess, we're going to also assign a blackboard because we have to do that manually right now. So let's drag over here first, and we're going to say use blackboard. And this node will either create a blackboard component or just assign one if a blackboard component already exists. So that's easy. In here, we want to select our custom blackboard, so the AI guard one. And after that, we're going to grab our behavior tree component, drag off here, and we're going to start the logic. And plug it in over here as well. So that's all we need to do in here. Let me double check. Yeah, that should be good. And now if our AI dies, we can simply destroy the component or stop the logic. So that's a bit easier to work with. Then we created the new function in our interface. So let's implement that one. Interfaces, double click our AI pawn died. And in here, let me change my notes quickly. So in here, we're going to get rid of that behavior tree component. So let's drag it in. And we're simply going to destroy component. We don't really need to stop the logic. We can just destroy it. And we want to do the same thing for our perception component. So let's drag that one in as well and simply hook it up to the same node. So this will make sure we don't have any perception or behavior running anymore. And now we're also going to grab our perceived actors array, and we're going to clear that. So if the perceived actors array is empty, then the function over here that we're using the timer for will automatically stop the timer. So that will make sure that the timer is also invalidated. And then over here, we're going to create one new variable and simply call this one is pawn dead. Nope. So we can tell if the pawn is dead or not by simply checking a boolean on our controller. So let's hook it up over here and make sure we set it to true. So that should be all for the AI controller. And now we also want to do a small thing inside of our guard. So let's open up the guard character. And in here, let me see. So we have the event graph. And over here we have the event point damage, where we deal the damage that we take. And at the end we kill our character if the health is 0. So let's turn this into a function to make things a little bit cleaner. So I'm going to select these two nodes, right click, and then collapse to function. I'm going to give it a server prefix because this only runs on the server, and then simply call this die. So this is where the pawn dies. And in here, we want to make sure that we call our interface function. So let's open up the function. And then we need to get our AI controller. So let's get an AI controller. And we need to hook up the controlled actor. So that's a reference to ourselves. And then we can simply call the AI pawn died interface function in here. So the message function, select this one and plug it in. So this will tell the controller that the pawn died. And then a little bonus that we could also do in here is detach our weapon component from our character. So the weapon falls from the AI's hands on the ground. So you could turn the weapon into a pickup or something like that. And to do that, we want to go to our components, drag in the weapon component. And we're simply going to detach it. So detach from component. We do need to make sure we set this to keep world for all 3 of them. After we detached it, we're going to set the collision profile name. So set collision profile name. And again, we're going to set this to ragdoll. Just like we did for the character mesh. And the last thing we want to do is drag off the weapon component again and set all bodies simulate physics. Plug it in as well and make sure we simulate physics. So this will make the weapon drop to the ground. Okay, that should be good. And now we want to go back to the event graph. So make sure that we actually call this server die function if the pawn dies. And let's add a little check in here to make sure we only call this once. So I'm going to disconnect the condition over here and grab an end node. And make sure we are actually alive. Or did we already do that at the beginning? Oh, we already did that at the beginning. I'm sorry. So we can pretty much just ignore that. Just plug it in like this. So this should work. And now if we kill our pawn, so let's open the gameplay debugger. We have the blackboard and the behavior tree, and let's grab the perception in here as well. So right now I'm being perceived because of the circle around me, and the AI starts chasing me, so he's aware. And as soon as I kill him, you can see the actual behavior tree info is gone, and I'm not being perceived anymore. There's no circle around me. And if I enable the AI category, you can also see the behavior is inactive and the tree is none. So that's a little bit better. Okay, so we have that part out of the way. Now let's refine our searching and chasing system and add a new state. To set up our new state, the first thing we want to do is go into the behavior folder, and we're going to add a new entry to the blackboard. So let's open our blackboard, add a new key, and this is going to be an object. We're going to add the spotted actor. so the actual reference to the actor and not just the location. With the spotted actor selected, we need to make sure we set the base class over here to be an actor. So that's good to go. Save the blackboard and get rid of it. Then we also want to open our enumeration for the AI states, and we're going to change this a little bit. So the aware state, I'm going to rename this to searching. And then we're going to add a new state, and this is going to be chasing. So you don't really want to change the order in here, so it's fine to rename things or add new enumerations, but if you go and mess around with the actual order, then you also need to change all of the switch on enumeration nodes in your blueprint and things like that. So you kind of want to avoid that, but just renaming something or adding new enumerators should not be an issue in most cases. So we have the blackboard and the enumeration set up and good to go. Now we want to go back to our AI controller, and we can actually do a lot of the stuff in here. First of all, let's go to our start aware state event. And we're going to change that up a little bit. So let's make a little bit of room over here. So start aware state, first of all, let's rename it because currently it's the searching state. So start searching state. And then we want to get rid of the spotted actor input because for searching we use a location and for chasing we use the actor. So we can get rid of this input. We're not going to use the get last perceived location in here. So let's delete that call. And then first let's grab our blackboard and we're going to clear a value. So let's look for clear value. And in case we are searching, we want to make sure that our spotted actor reference on the blackboard is empty. So we're going to clear the spotted actor and hook that one up. And then we're going to set the spotted actor location. So this node was already in here. We should be able to just hook it up. Although now we don't have an input over here. So we're going to pass this one on to the actual event. And this is going to be our search location. So first of all, clear value spotted actor, then set value as vector spotted actor location. Then we're going to set the current state. So we can leave this in, that's good. And after that, we're going to set the aware icon visibility. So we can also keep that one. That's also good to go. Then we want to go to our AI change state event. So that's over here. And we removed the spotted actor over here. So we're going to get rid of this input. And instead, we're going to pass on the search location as well. So for the AI change state event, we have both inputs now, a spotted actor and a search location. Then let's go to our actual perception event. So that's at the beginning over here. Target perception updated. So what we do over here. So this is the second branch, AI and sense hearing. And if we hear a gunshot, then we start chasing or searching in this case. If the player is actually outside of our short hearing range. We can keep that, that's good. But we do want to make sure that if we fire a bullet while our AI can see us, he will immediately go into chasing state and not into searching state. So depending on if we are visible, we want to do something different in here. So we're going to grab the false branch and let's disconnect it. Then we're going to hook up a second branch over here. And the first thing we want to do is make sure that we actually perceived this actor that fired the shot. So we're going to grab our perceived actors array and we're going to find an item in here. And the item that we want to find is the actual actor that comes all the way from the event. So let's grab that one over here and plug it in. Now, if this returns greater than or equal to 0, that means we actually found the actor in the array. So let's plug that in as the condition. Oh. And if the actor is in the array, that doesn't mean we actually perceived him successfully. So we're going to grab the perceived successfully array as well. And from here, we're going to get a copy. And we want to get the copy from the index that we found in the perceived actors array. And then we can hook that one up to a branch as well. So this one goes in the true pin. This one goes into the condition. And then if we actually perceived him successfully, then we can start chasing. So let's grab our change state node, hook it up over here. The new state is going to be chasing, and if we want to chase, we need the actual actor reference. So we're going to grab the spotted actor and simply plug it into the actor from the event over here. And for the other branch, so if we cannot see the AI, or sorry, the player that actually fired the gunshot, then we're going to do the searching state. So in that case, we want to disconnect the spotted actor, and we're going to plug in the search location over here into the stimuli for the stimulus location. And then the AI will start investigating that location. So that should be good. And then we also want to grab the false branch over here from the perceived actors find node and also plug that into the searching state. Like so. So this will make sure that we immediately start chasing if we can see the player that fired the gunshot. So that's a bit cleaner. And then we also want to go a little bit down to the actual looping event, so the awareness loop. And in here, we trigger the aware state searching, and we want to change this one into the chasing state. So we're going to change this into chasing. This happens when the sidebar above the AI is filled up completely and the AI successfully spotted the player. So then we're going to start chasing immediately. Okay, that should be good to go. And now we want to set up our new state. So that's the actual chasing state that we are triggering here. So we're still in our AI controller. And first of all, let's set up the new event to start our chasing state. So we're going to create a new custom event and call this start chasing state. And for this event, we need to give it an input, and that's the spotted actor. So let's add that one first, spotted actor, and that's an actor reference. Like so. And so we could grab a bunch of nodes from our start searching state. So in fact, I'm just going to copy all of them for now and paste them over here. Hook it up. So the current state is going to be chasing. Then we want to clear our spotted actor location. So we need to swap these keys around. We're going to clear the spotted actor location. And we're going to set a value as object. So we're going to drag off the blackboard and set an object. So that's going to be our spotted actor. So we need to grab the input from the event over here and make sure that we change this to the spotted actor and not the spotted actor location. So that's going to be the key name. After that, we're going to set our new state, so we can keep that node, that's fine. And we also want to set our awareness icon, so we're going to keep this node as well, set aware icon visibility and set it to true. Then we're going to add a second event that's going to keep track of the visibility of the player that we are chasing. So if we lose sight, we start searching. So we're going to create a second custom event over here. Oh. And let's call this one the chasing player loop. And for this, we also need the actor as an input. So let's add a new input and call this the spotted actor again. So that's an actor variable. Now we're going to grab a branch, and first of all let's check if we might have died. So we're going to grab our isSpawn dead, and if we are dead we want to stop looping over here, so we're not going to do anything. Then we're going to grab a second branch, and we need to hook it up to the false pin because we're not dead. And in this case, we're going to grab our spotted actor, and again, we're going to find it inside of the perceived actors array. So let's drag in the perceived actors, and from here, we're going to find an item, plug in the spotted actor, and if this is greater than or equal to 0, then we can actually see him. So if this is true, then we want to keep looping this function or event. And if this is false, then we want to start searching. Now I'm going to add a little variable in here, a float, that keeps count of how long we lost sight. So I'm going to make a small delay in there. So if we go around the corner, it takes about 1 or 2 seconds. We can specify that time before the AI actually loses sight and starts chasing, to prevent that if we just cut a corner before he doesn't lose our sight, if that makes sense. So it just feels a little bit more natural if we add a small delay in here. And how are we going to do that? Well, we're going to add a new timer in here. So let's call this our lose chase timer. And that's simply going to be a float. Now we need to know if we perceive this actor successfully. So just like in the previous event where we used it, we need to check our perceived successfully array. So let's do that first. Drag it in, get a copy, and check the item that we found in here. So hook this one up to the true pin in this case, and plug it in like this. So if we perceived him successfully, we want to keep chasing. So we're going to add a delay in here. Let's make it 0.2 seconds. That's fine. Then we're going to grab our lose chase timer and reset it to 0 because we perceived him successfully. So we can safely reset it over here. And then we're simply going to call this event again. So instead of grabbing the execution pin and plugging it in over here, we're simply going to call our chase player loop. Chase. Oh, really? I'm not even sure how I called it. Chasing player loop. Okay. And make sure we plug in the spotted actor from the event over here. So that's how you can create a loop as well. Make sure you have a delay in here. Otherwise, you're going to get an infinite loop or a stack error and it's going to crash. Now we need to get these false pins over here, and for those we want to start counting the timer. So we're going to grab a setter for the lose chase timer and hook it up to both of the false pins. Also grab a getter and we're going to add 0.2 seconds. So let's add a float and make it 0.2, plug it in over here. Then we need another branch to check the actual value. So let's drag off the lose chase timer. And if this is greater than or equal to, and over here you can define how long it takes for the AI to actually lose sight. So I'm going to set it to 1.5 seconds, something like that. Make it 1-2 seconds. You can play around with it. Now, if this is true, then we actually lost sight. So in this case, first of all, let's make sure we reset the timer again. And then we're going to call our get last perceived location and plug it in over here. The spotted actor comes from the event, so we can grab that one over here. And then we can call our start searching state. And simply plug in the search location like so. So this will make sure we start searching if we don't see the player anymore. And over here for the false pin, we want to simply do the counting. So we're going to add a delay of 0.2 seconds because we added 0.2 over here. And then we're going to reset the function. So we're going to do our chasing player loop again. And also grab the spotted actor from the event. So this will make sure that he will start searching as soon as he lost sight for 1.5 seconds. Now we want to go back to our start. So we want to go back to our start chasing state. I'm sorry, that was confusing. And in here, we need to call this chasing player loop. So let's do that over here. chasing player loop, and we need to hook up our spotted actor again. There we go. So that should work. Now we need to implement this into our AI change state function as well. So let's go to AI change state over here, and let's make a little bit of extra room. So we have a new enumeration in here, and we want to set that one up. So we're going to grab another switch on enum, plug this one into the chasing pin, like so. And then the new state comes from the event, so we can plug that in over here. So if our current state is chasing, then we can go to either searching or combat. So if we grab the searching pin over here, we want to plug it into start searching state. And we also want to grab the combat one and plug that into the start combat over here. And then we also need to go to this node in the middle. So if our current state is searching, then we can go to either chasing. So from here, we want to drag off chasing, and we're going to call our start chasing state. And in here, plug in the spotted actor from the event. So that one is hooked up. And then we should be, oh no, we also want to hook up the chasing from idle. So if we are currently idle, we can also go directly into chasing. So from here, we also want to grab the pin and plug it into start chasing state. So that should make that part work. And now we want to make a small adjustment to the awareness loop. So let's go to the awareness loop event. Let's move this one up here. So we have a switch on enum in the awareness loop, and currently if we are searching, we disable the actual bar above the AI head. And we want to change this one to chasing. So we're going to swap this one over to chasing, and we're going to grab the searching pin and also hook it up to the branch over here. So if we are idle or if we are searching, we can spot a player. One small thing we could do in here is increase this number so the AI spots us a little bit faster, and that's a little bit easier to test. So you don't really need to do this, but I'm going to increase this one to 0.4. So I'm going to only take 2.5 seconds to spot a player instead of 5 seconds. So keep note down here, it's still doing minus 0.2, so it will take 5 seconds to lose sight and 2.5 seconds to successfully spot a player. But this is mainly for testing, so you don't really have to do it. Let's see, do we need to do anything else in here? No, this should be good to go. Now there are a few small things we need to do inside of the behavior tree to make this work, and then we should be good to go. Let's open our behavior tree over here. And this shouldn't be too bad. So currently we already have the searching state in here, and because we made a separate chasing state, we don't need to worry about this. This should be good. So I'm going to move the chasing state in between here. You can also add it right after it. It doesn't really matter in this case, but it just looks a bit cleaner because the chasing state isn't that big. So I'm going to move it over here. And from the selector, we're going to add a new sequence. And for the sequence, we want to add a condition to make sure that our state is the chasing state. So we're going to add a decorator blackboard. Select this one, and we want to make sure that our current state is equal to chasing. No, over here. So is equal to chasing current state. And we also want to make sure that our observer aborts itself. So if the result of this equation changes, then this will be aborted and the tree will be re-evaluated. The sequence that we want to do is pretty simple. We're going to stop all montages and change the move speed. So let's copy and paste these nodes over here to make sure that those are actually the same. And after that, we simply want to move to. So we're going to drag off, add a task, and select move to. Select the node over here, and we want to move to our spotted actor. So we need to change that one over here. And then we also want to enable observe blackboard value. So if we move around, then the actual goal location of the move will be adjusted. So this will actually follow the player if we move around. So this should be good to go. Now there is one thing we need to do at the beginning over here. If our current state is equal to idle, we want to select this decorator and also set the abort over here to cell. So if we are currently going back to our guard spot, and while we are walking back we spot another player, we immediately want to abort this. So that's what this does over here. And that should be pretty much it. So right now, if we save it, we should be able to test it. So let's hit play and run a little test in here. I'm gonna enable my gameplay debugger and also enable my perception. So first of all, if I fire a shot outside of the vision range, the AI should start searching. So we get the searching state, and right now he can still perceive us. If he sees us successfully, he's going into chasing state. And unfortunately, he got a little bit too close, so we're in combat right now. That's not what we wanted, but that part worked good. So we could also be inside of the vision range and then fire a shot, and then we will immediately be spotted and he starts chasing us. So let's try this again. I'm going around the corner and he's gonna lose sight. Oh, damn it. So again, I triggered the combat state. So I want to keep a little bit more distance. So chasing. I'm gonna cut around the corner over here, and let's enable the debugger as well. So you can see for the current state it changed into searching, and right now the AI will search the last known location. So if he doesn't spot anything over there, he should go back to idle. And otherwise, if we fire a gunshot, for example, over here, then he will start searching this location again. Now, while he is searching, he can also spot us, and then he will go back into chasing us. So I think we have that pretty much working, and we should also be able to test the little delay that we have. So currently we are being chased. And if we keep him a little bit closer and cut around the corner, dang it. So it should take 1.5 seconds for the AI to actually lose sight and start chasing. So let's make sure that works as well. So over here, I'm cutting the corner. That took a little bit too long. So we might want to increase that delay. You kind of want to play around with it a little bit. So obviously you don't want to make it too long either, because that's a bit weird as well. So that's the delay over here inside of our chasing player loop. So we have it set to 1.5 seconds over here. So right now let's set it to 5 seconds so we can properly test this to see if that's working. So I'm being chased, so I need to be spotted successfully like I am now. And if I cut around the corner, so he's still chasing, and now he sees me again, so that will reset the timer and he will keep chasing me. So that part is actually working as well. So let's turn this back down again, 1.5 seconds, and that should be fine for now. So we have a new state added, and we can make a nice difference between them to set them up inside of our behavior tree. So that's nice. Now there's one small thing that I want to do, and that's make the AI be able to find corpses of other AI. And then in the next video, we're going to expand on that and actually make it so that AI can call other AI if he finds a corpse, and they will start searching together, for example. So to make sure that we can find corpses, we also want to do something inside of our card. So let's open up the card character first. And in here, we want to go to our server die function. So let's open this one up. And we're simply going to add a perception stimuli component so that we can be perceived by the perception of other AI. So at the end of the function over here, let's add a perception stimuli source component. we need to have this node selected and set it up on the right side. So we're going to auto register as source, and we want to make sure that we add one sense and set this one to the side sense. So then we are perceivable by the side sense. And there's another thing that we're going to do to identify an actual corpse, and that is set tag. So we're going to right click and get the tags. So that's simply an array of names. And in here, we're going to add a tag. So add an item, plug it in over here, and we're going to give all corpses the tag AI corpse. So AI underscore corpse. So we can identify it pretty easily. So these tags are also in the class defaults. If you go to the advanced setting over here, so we have actor, you can expand advanced, and over here you have the tags array. So that's the same array we're using over here. You can set up name tags and check against those. So that's all we need to do inside of the card, and then we want to go inside of the actual AI controller, and we have our perception updated event. So target perception updated, sense class is side, and we perceived something successfully over here. So the second branch, we're going to disconnect this branch, and all we're going to do for now is simply identify that corpse. So we're not going to add any behavior if we find a corpse. We're going to get back to that in the next video, but I just want to have this set up quickly. So if we grab the actor that we perceived, we're going to check if the actor has a tag. So actor has tag. And we simply want to check for the AI corpse tag. And then we can add a branch in here, hook that one up to the previous branch. So if this is false, we're going to do what we used to do. So that's hook it back up to the add unique node. And if this is true, then we found a corpse of another AI. So for now, I'm simply going to add a print string so we can see this is working. And then in the next video, we're going to expand this logic. So let's make this something like corpse found. And let's make it red for 5 seconds. There we go. Compile and save it. So now we need to make sure that we have 2 AIs in our level. So let's open up the viewport and add a second one in here. And also add a second guard spot probably. There we go. So with the AI selected, we're going to go to the details panel, and then we want to make sure that we set up the weapon. So that's not really important right now, but we also want to set our guard spot. So we're going to click the little eyedropper and then select the guard spot in here. So we have guard spot number 2 assigned to this AI. And that should be all we need to do. So let's have a little test. Let's save it and hit play. Now there is one annoying thing about the gameplay debugger, and please, if anybody knows the answer, drop it down in the comments below. So a lot of the times after you used the gameplay debugger, your prints from the print string will not show up anymore. And for me, I haven't found a consistent solution. The only thing that pretty much works is restarting the editor, but that gets a little bit annoying. So what you could do is open the actual output log, and the prints will show up in your output log as well. So we are going to keep this one on the side. Let's clear it. And now we should be able to see the corpse found thingy inside of our log. So let's hit play and let's resize this a little bit as well. This is pretty annoying. There we go. So now we should be able to see it. Let me get the viewport back in here. So I'm going to trigger this first AI and have it walk towards me a little bit, and then I'm going to kill him. There we go. And now I'm going to grab the second AI and make sure that he starts chasing me, and then if he sees the corpse, so you can see down here, we have the corpse found print. So the AI actually perceived the corpse, and that's good to go. So we actually have a message in here. So that's for searching for an invalid index. Let me double check if this is important or not, and I'm gonna get back to that in the next video. It's not an actual error, it's just warning us that we use -1 as an index. So we have the finding corpse set up as well, and if we enable our perception, so you can see over here the AI actually perceived the corpse. This is the capsule component, so it looks a bit off, but it perceived the actual corpse. So we're gonna work with that in the next episode. So that's all I got for you guys today. Hope you enjoyed the video. If you did, please consider dropping a like. That helps the channel tremendously. And I'll be back in the next video. Thanks guys and girls. Bye bye.